geometry. You have some algebra review to do. We're going to start with some systems of linear equations, and I'm also going to have you guys do some proportions. So just to start out, going over the packet that I've posted on Moodle, the packet is from a workbook, and it has some vocabulary, and it has an example, and then some problems that follow. I'm going to assign you on the first page numbers 1 and 4, and that's on page 153. And then on page 154, I want you to do number 13 and 16 on page 154. And then on page 155, I want you to do 10 through 13. On page 156, I want you to do 25 and 28. And then on page 116, I want you to do 23, 29, and 38. Those are the ones that I've posted, and the pages that I'm using are these pages that you're going to find in the corner. The first thing that you want to do when you're solving a system by graphing, every time that I have the problem, I write it out, write each equation out separately, side by side, so that I can easily solve for y, put it into the slope-intercept form without having to deal with each one of the problems. If I stacked this one underneath here, then I would have to write it below, and it gets too confusing. Keep it separate. Keep it side by side, not stacked. Also, another thing that I do is whenever I'm solving for slope-intercept form, I keep it in the y equals mx plus b form, so that I have my y alone on one side without a coefficient. It has a coefficient of 1. The slope times the x, so the coefficient of x out in front, x term out in front, and then plus the constant term, which is going to represent my intercept. Let's go ahead and see what this is by graphing. The other tool that I want you guys to use is a ruler, so that we can have some accuracy with graphing by systems. So let's go ahead and draw in our axes that we're going to use for this problem with a ruler. And I know on this video it's a little bit difficult to see. Oh, I'm going to use blue pen. Oh my gosh. Okay, so it's a little bit easier to see on here with the axes in blue. Now, my first equation is y equals negative 2x plus 1. Now what I've done here is I've done a little algebra 2 trick here by calling one of my equations y1 and my second equation y2. That's just so I can keep my work organized. So my first equation has a y-intercept of 1, and so I'm going to go from the origin, I'm going to plot the point 0, 1, and then I'm going to use my slope, which is negative 2, which means I'm going to decrease in the output by 2, so that means go down 2, 1, 2, and then right 1. So I went minus 2 and then plus 1, down 2, right 1. And now I have 2 points on my line. So I'm going to take my ruler and I'm going to make a light line. Just in case I make any mistakes, I can go back and easily erase it and it doesn't make that much of an issue. The next one, negative x plus 3, my y-intercept is 0, 3. And my slope is negative 1, 1, which means I go down 1 and right 1. And then I can see, just using my ruler right now, I can right away see that my point of intersection. Now I know it's a little bit off and it looks like it's on that one, but that's probably an error of graphing. So I'm going to choose this as my intersection. This is 1, 2, negative 2, 2, 1, 2, 3, negative 2, 5. Okay, so that's going to be the equation, the solution that I'm going to check. So I'm going to check if x equals negative 2 and y equals 5, does that work in both of my original equations? Well, let's test it. So in 2x plus y equals 1, if I substitute in a negative 2 and for x and a 5 for y, I get negative 4 plus 5, which is 1. So 1 equals 1, that checks out. Now for my second equation, x plus y equals 3. If I say negative 2 plus 5 equals 3, 3 equals 3, that also checks out. And so I know for sure that for number 6, my solution is negative 2, 5. Write your solution as an ordered pair after you've checked it and circle it so it's really easy to see your answer. Make sure that you've also labeled the y-intercepts, or I should say, label at least the solution on your graphing. Now, let's do another example. So, the next example, we're going to have to put this into slope-intercept form. So, subtract x on both sides, 2y equals negative x minus 4, and divide everything by 2. I want you to show this step of dividing everything by 2. That's the only way you're going to make sure that you get everything correct when you put it into slope-intercept form. Divide everything by 2. Y equals negative 1/2 x plus 4. Now, if you guys remember way back when we talked about parallel lines, lines that are parallel have the same slope but a different y-intercept. So already I can tell that these are probably not going to have a solution. I'm going to guess these are parallel. That's my first guess. Let's go ahead and graph them. So we have that y1 is equal to negative 1/2 x minus 2, and y2 is equal to negative 1/2 x plus 4. Drawing in my axes in my blue pen so that you guys can see it on the video. Using a ruler, it's another way to get accuracy. If you don't use a ruler on these systems problems, you're probably going to get some of them wrong. And yes, you're probably going to have to remind me to pass out rulers in class. Alright, so y1 is negative x, 1/2 x minus 2. So the y-intercept is 2 and the slope is down 1, right 2. Lightly draw in your line through those 2 points. And graph the other one. Now we have a y-intercept of 4, 1, 2, 3, 4, and a slope of negative 1, 2 again. Doesn't matter if the line goes through your point here. Now you can see that these lines are parallel, and so there's no intersection, which means that there's no solution. I want you to write as your solution, no solution, they are parallel, because that will reiterate the idea that whenever you have two parallel lines, they're not going to intersect, they're not going to have a solution. Now, another scenario that we have with graphing is when we have the same line. If we solve for y here, we get that both equations are the same. We get that y equals x minus 4 and y equals x minus 4. That means that there's going to be infinitely many intersections. So on the graph, you're still going to graph your function. You're still going to write in your y1 as the original equation and y2 as the original equation, but this time you're going to actually graph them as the same one. So really you're only going to graph them once. 0, -4, and a slope of 1, 1. This makes the same line. So on your answer sheet, you're going to write infinitely many solutions, same line. Mathematically, we're saying that anytime you have two equations that graph the same line, they have infinitely many intersections. Every single point, they intersect at every single point, which means that they're going to have infinitely many solutions, and it is the same line.